Here's something almost nobody gets right about human history. Every human being alive today shares one original homeland: Africa. Our earliest ancestors were covered in thick body hair, just like other primates. Underneath that fur, scientists believed the skin itself was actually pale. Then something changed everything. Early humans began losing their body hair. Losing fur helped our ancestors sweat and cool down while hunting. But losing fur created a brand new problem: exposed, unprotected skin. That exposed skin now faced intense equatorial sunlight every single day. Strong ultraviolet light can damage far more than just the surface of skin. Specifically, UV light breaks down a vital nutrient called folate. Folate is essential for healthy pregnancies and proper cell division. Low folate levels were linked to serious birth defects and low fertility. This meant pale, unprotected skin was a genuine survival disadvantage. Evolution needed a natural sunscreen, and it found one: melanin. Melanin is the natural pigment responsible for darker skin tones. More melanin means stronger natural protection against ultraviolet radiation. Over generations, humans near the equator evolved deeply pigmented dark skin. This wasn't a random trait. It was a direct evolutionary response to sunlight. For most of human history, dark skin was the only skin humans had. So how and why did any human population ever become lighter? The answer begins with one of humanity's greatest journeys: migration. Around 70,000 years ago, humans began leaving Africa entirely. These migrations eventually reached Europe, Asia, and far beyond. As humans moved north, something crucial changed: the sunlight itself. Higher latitudes simply receive far weaker, more angled sunlight. This weaker sunlight created a brand new survival problem entirely. Human skin actually needs sunlight to produce vitamin D naturally. Vitamin D is essential for strong bones and a healthy immune system. Dark skin, so useful near the equator, now blocked too much sunlight. In low sunlight regions, that same protective melanin became a disadvantage. Populations with too little vitamin D suffered weakened bones and illness. So evolution reversed course, favoring lighter, more UV-permeable skin. Lighter skin allowed more sunlight through, boosting vitamin D production. This is the core trade-off behind all human skin color variation. Too much sun destroys folate, too little sun blocks vitamin D. Skin color evolved as a precise balancing act between those two forces. That's why skin tone naturally maps almost perfectly onto sunlight intensity worldwide. This pattern held true across nearly every continent humans settled. But the story gets far stranger once genetics enters the picture. Scientists identified specific genes directly responsible for skin. One key gene involved is called SLC24A5. A single mutation in this gene can significantly lighten skin tone. Another important gene, SLC45A2, plays a similar lightening role. A gene called MC1R also strongly influences pigment production. These mutations didn't appear all at once, they spread gradually. Natural selection favored these mutations only where sunlight was weak. Over many generations, entire populations carried these lightening mutations. But here's where things take a genuinely surprising turn. Europeans and East Asians developed lighter skin through different genes entirely. This is called convergent evolution. The same result, separate causes. In other words, light skin evolved more than once, independently. This proves lighter skin wasn't one single event in human history. It was a repeated solution to the exact same environmental problem. Neanderthals may have also played a surprising role in this story. Neanderthals had already lived in Europe for hundreds of thousands of years. Some evidence suggests Neanderthals had already evolved lighter skin themselves. When humans and Neanderthals met, interbreeding occasionally occurred between them. This interbreeding may have passed some pigmentation genes to modern humans. In other words, some Europeans may carry ancient Neanderthal pigmentation genes. This adds a genuinely unexpected twist to human evolutionary history. But the biggest surprise of all came from ancient DNA itself. In 1903, a nearly complete ancient skeleton was found in Britain. Scientists later nicknamed this 10,000-year-old skeleton Cheddar Man. In 2018, researchers finally sequenced his full genetic code. The results shocked almost everyone who expected pale British ancestry. Cheddar Man likely had dark brown skin and striking blue eyes. This meant early Britons were still dark-skinned far later than assumed. Full light skin in Europe is actually a remarkably recent development. Some estimates place widespread light skin in Europe within just a few thousand years. In evolutionary terms, that's an incredibly fast, almost sudden change. So what caused this sudden acceleration in skin lightening specifically? The answer connects directly to a massive shift in human lifestyle. Farming. Before farming, humans got vitamin D from hunted meat and fish. Farming diets relied heavily on grains, which contain very little vitamin D. This created a new, more urgent vitamin D shortage in farming communities. That shortage placed intense new pressure on skin to lighten faster. In other words, agriculture itself may have accelerated human evolution. A change in diet reshaped human biology in a matter of millennia. This is one of the clearest examples of culture driving human evolution. But not every population followed this exact same lightening pattern. Consider the Inuit people, living at extremely high, sun-poor latitudes. Based on sunlight alone, we'd expect the Inuit to have very light skin. Yet many Inuit populations retained noticeably darker skin than expected. The reason comes down entirely to their traditional diet once again. Inuit diets are extremely rich in vitamin D from fish and marine fat. That dietary vitamin D reduced the evolutionary pressure to lighten skin. This proves skin color was never only about latitude alone. Diet and lifestyle shaped this evolution just as powerfully as sunlight did. This same nuance appears in high-altitude tropical populations as well. High altitude means thinner atmosphere and stronger ultraviolet exposure. So even far from the equator, some populations still needed darker skin. Skin color, it turns out, responds to sunlight strength, not distance alone. Scientists call this entire global relationship the vitamin D hypothesis. It remains the leading, most well-supported explanation among researchers today. Other theories exist too, including one involving sexual selection. Some researchers suggest certain skin tones became culturally preferred over time. This theory remains debated, without the strong evidence vitamin D has. Disease resistance may have played a smaller, secondary role too. Darker skin may offer some added protection against certain infections. Even so, most researchers agree sunlight remains the dominant driving force. So let's step back and look at the complete evolutionary timeline. First, early humans lost their fur and exposed their pale skin. Then, strong equatorial sunlight pushed human skin to evolve darker. For tens of thousands of years, humanity remained almost entirely dark-skinned. Then migration carried some populations far from the strong equatorial sun. Weaker sunlight in these new regions created a vitamin D shortage. That shortage triggered new, independent mutations toward lighter skin. Farming later intensified this process, accelerating the shift even further. Within just a few thousand years, entire regions had visibly lightened. Meanwhile, populations with vitamin D-rich diets stayed comparatively darker. The full range of human skin tones today reflects thousands of these choices. Every shade represents a precise, localized answer to sunlight and diet. None of these variations reflect ability, intelligence, or human worth. They reflect nothing more than climate, diet, and simple biology. Unfortunately, this scientific fact was ignored for much of human history. Societies built entire hierarchies on top of this simple biological adaptation. Genetics tells a very different, far more unifying story than that. Every human population traces back to the exact same African ancestors. Skin color is simply one of evolution's most visible adaptive signatures. It changed because environments changed. Nothing deeper than that. And this evolutionary story is still technically ongoing today. Modern lifestyles, sunscreen, and indoor living now change these pressures again. Vitamin D deficiency is actually rising again in many modern societies. This is largely because we now spend far less time outdoors overall. In a strange way, evolution's original pressures haven't fully disappeared. They've simply shifted shape, adapting once again to modern human behavior. So the next time you consider human skin color, remember the real order. Dark skin came first, born from the harsh African sun itself. Lighter skin came later, a recent, practical response to a changing world. Every shade of human skin is simply the same ancient story, written differently by the sun.